Hello, my name is Alba, but you can call me Natalia. And I work in the Center for Climate Change, and I will show you the fair use mapping based on machine reasoning and FAIR principles. And first, I want to briefly introduce to these concepts, machine reasoning and FAIR principles. So machine reasoning is an enhanced form of artificial intelligence to perform the logic reasoning that leads the machine through the steps of a complex process, and it adapts to real-time change to execute the functions. The machine reasoning has two main components. The first component is a knowledge base that acts as a collection of facts, rules, and relationships related to a specific domain of interest, represented in a symbolic form that usually is the semantics or ontologies, and that a computer and humans can understand. And then is the engine, that is a general purpose inference that describes how to manipulate and combine these symbols, semantics and ontologies. So we can say that ontologies or semantics function like a brain. They work and reason with concepts and relationships in ways that are close to the way the humans perceive. And to the other side, the first principles, they said that the model's resources and its metadata has to be findable, accessible, interoperable, and reusable. Findable means that the model resources and the metadata are easy to find by humans and computer systems. The accessibility is about storage for the long term and easily accessed and download for humans and machines. Then the interoperability means that it should be ready to interpret, exchange, and combine automatically with other data sets. And then the reusability, it means that have to be reused in other future research, the models and the resources. So I want to show you how I model fire risk consistently by using both machine reasoning and FAIR principles. Although both machine learning and FAIR principles are used most of the parts of the workflow, we will see particular use of each of one of the FAIR principles by the use of semantics. For the use of semantics and the machine reasoning, I use the KLab software, that is a software that we developed in the Center for Climate Change. So first of all, when I start the model, I have faced the difficulties of finding proper data due to the different data sources. In this case, as you can see, my data comes from different sources, like the Sicilian government, the Copernicus dataset, or the University of Catania. So in order to make the data more findable, after the gist processing and the data preparation, I upload all the data in the GeoServer through the Docker, and then I create, or in some cases I reuse, the semantics that was in the KLab to define the data. So that is so now that data that was in different places now was understandable for both computer and humans. So this is an example of how we define in this case, the land cover. After the new semantics are defined, the data and the complete models are easily findable, and the final output is shown on the web interface that is called K-Explorer. So again, once the data and models are semantically, once I find the data, the other problem was the accessibility. So sometimes the data is open source, and you can easily download, but sometimes is on demand. So again, once the data was semantically annotated, all the data and models can be downloaded. In this case, through this arrow, you can download all the complete the output of the models and all the data input data that the model needs. And moreover, all the code is open source, avoiding the black box models. And this is how I wrote semantically the fire currents model. To combine data models in an automated way to make them interoperable, we create new models based on semantics. In this case, the model was a machine learning model that computes the probability of fire occurrence. I did this model with the Bayesian networks, and I ran in Kayla with more than 14,000 historical fire and non-fire data, and the accuracy was 84%. This is how I semantically annotate the machine learning model, and as you can see, it's perfectly understandable for any kind of user, even non-programmers users. And at the same time, it's understandable for the machines too. So here I tell to the machine that he has to learn something. In this case, is occurrence of fire in a site, and I want that the machine computes the uncertainty of this occurrence of fire, observing all of these instances that are all the predictors. And then I tell him that I want that he use the weapon algorithm, in this case the Bayesian networks. For the first fire-based model, we want to calculate the vulnerability of the different ecosystem services against the fire hazard. We were able to reuse other semantic models that were created by researchers experts in those ecosystem services fields that was in Kayla. So when I asked of any of these new ecosystem services models, the Kayla creates the data flow on the fly, where show the steps needed to solve this model. Moreover, to ensure the traceability and reliability of the model, the interface creates a report on the fly that explains each model used and the reference of the peer-reviewed publication of those models. And finally, the same model, thanks to the semantics, can be reused with different spatial-temporal data if the calibration of the model allows it. The information related to its source appears on the web interface to know which data is used. I want to show you a video of the use of the Kayla. I ran another model because the fire occurrence model is not finished yet. Is a net pollination model. First, I take the context. In this case, is Valencia. I can write in the bar, and it's able to find it. And then there are some ecosystem services that. Sorry, I stopped. There are some pre-alternative ecosystem services that those models that other researchers develop and are in the platform. So now I ask first build the data flow, and I can click in any of the boxes, and the Scale show me what it's doing. And this is the first of the list of the inputs. Sorry, it goes so fast. First of the inputs that read the model, and if I click, I can see the source of this model, of this data. Then if I come back to Calab, I can see the report is starting, but it's not finished. So start with the references. And now some of the inputs that need the model are starting to appear. I can click one of them. In this case, I will click to uncover type. And I can see on the K-Explorer, and I can click to know And then I can download with GeoTIFF or PNG, and I can see the histogram information. Then the net value of pollination model is computed, and as the other data I can see, and I can click on it. Finally, the report is finished with all of the information, and if I run another model, the information of the new model will be added on this report. I can see the figures that appears on the report, and then I can see the data flow in semantics way to code. So the speed of the model depends on the resolution and the internet connection. And finally, this is the team that we work on this project.